Section 2.4 is variables and equations. I can solve equations with variables. An equation is a mathematical sentence formed by placing an equal sign between two expressions. A solution of an equation with a variable is a number that produces a true statement when it's substituted for the variable. So if we plug it back in and both sides of our equation equal the same thing when we simplify them down, then it is a solution. So here we're going to start off with verbal sentences and put them into equations, which are just mathematical sentences. So sum means we're going to add of x and 6 is a math word that means equals 9. So sum means I'm going to add of these two things. So x plus 6 is means equals 9. The difference means I'm going to subtract of 12 and y is again means equals 15. So difference again means I'm going to subtract difference of 12 and y. So 12 minus y is equals 15. The product is a word that means multiplication of -4 and p means equals 32. So again, product means I'm going to multiply, and the things that I'm multiplying are -4 and p. -4 times p equals for is and 32. We could also just write -4p equals 32. We don't need to have that sign in the middle if we don't want to. And quotient here means we're going to divide of n and 2 is again means equals 9. So n divided by 2 is 9. We can write it as a fraction, or we can write n divided by 2 is 9. And it goes in order here. So quotient of n and 2 is 9. So again, either as a fraction or with a division sign. Here we're going to tell whether 9 or 7 is a solution of our equation. So I know what 9 is, or what my variable is. This is the number I'm checking. So I plug it in for my variable. So instead of an x, I have a 9. And I bring down the rest of my expression. Again, I plug the number I'm checking in for my variable, the part that's unknown. On my left side, then I'm going to simplify. 9 minus 5 is 4. I didn't change the fact that it's equals, and I didn't change that 2. Does 4 equal 2? Nope. So is this a solution? No. Same idea here with b. We want to know if 7 is a solution. So I'm going to take 7 and I'm going to plug it in to see if it's one of my solutions, to see if it fills in for my variable. And I didn't change anything else in my equation. So I'm going to keep the minus 5 equals 2. 7 minus 5 gives me 2. And again, I didn't change the fact that it equals 2. Now I check. Does 2 equal 2? Yes, it does. So if it makes both sides the same, if it's true, then yes, it's a solution. Now feel free to pause here and give this a try. The sum means we're going to add of 3 and z means equals -10. Remember, we treat our variables just like numbers. So I circled it just like I did my 3 and my -10. Now, sum means we're going to add, and the things that we're going to add are the 3 and the z. And it is, so equals -10. The quotient means we're going to divide of m and 6 means equals 4. So again, when we have quotients, we can either write them as a fraction, or I can write them with division. My numbers have to go in order, so of m means m goes first, and 6 means 6 goes second, means equals 4. So either one of those would have worked. Here we're going to check to see if -5 or 5, if either one of these happens to be a solution. So I'm going to plug -5 in for my variable, my unknown. That's what we're checking. I have -8, and then I have my unknown, which here we're going to check a -5, and it's going to give me 40. We're actually going to multiply here and check. -8 times -5 gives me a positive. Two negatives when we multiply make a positive. 40. And 40 does equal 40, so yes, -5 is a solution. Now I'm going to check 5. I'm going to plug it in for y. Make it a +5 here. Positive times a negative gives me a -40. -40 does not equal 40, so here we get no. 5 is not a solution. Finding all the solutions of an equation is called solving the equation. We can use mental math to solve and check a simple equation by thinking of the equation as a question. So here I have x plus 3 equals 11. What it's asking me is what number plus 3 is 11 or equals 11. So if we think in our heads, what number can we add 3 to get to 11? Then we're going to get 8. 16 minus what number gives us 9? Well, 16 minus 7 is how we get to 9. Here I have 20 equals 5 times what number? Well, 4 times 5 is how I get to 20. And what number can I divide by 6 and get -3? Well, since it's negative, we know that our answer needs to be negative, and 18 divided by 6 is how I get to 3. So think of these as questions, kind of work backwards. That's one of our problem-solving strategies. Feel free to pause here and give this a try. We're going to solve the equation using mental math. So what number can I subtract 10 from and get to 7? Well, 17, if I subtract 10, gives me 7. Here, we're looking for 2 plus what number gets me to -6. Well, I know it's negative. 2 plus -8 gets me to -6. Three times what number gives me a -15. I know it has to be negative because I have to multiply by a negative to get a negative if I have a positive already. And 3 times 5 is how I get to 15. 36 divided by what number gets me to 4? Well, 36 divided by 9 gives me 4. From 1998 to 2002, biologist Jane Shen Miller grew several lotus plants from ancient seeds she found in China. The oldest seed was about 500 years old. Estimate the year when this seed was formed. So, we're going to estimate here, which means 1998 to 2002 is approximately the year 2000. And we want to know, it was about 500 years ago. And we want to know when the seed was formed. So, we want to know, when was it formed? And it was about 500 years ago. So it was formed, and then 500 years passed, and we got to about 2000. So what number can I add 500 to get to 2000? 1500. So about the year 1500 is when the seed was formed. Now feel free to pause here and give this a try. Go-kart rides cost $5 each at a county fair. During the first day of the fair, the go-kart operator takes in a total of $1,000. How many times did people ride the go-karts that day? Write and solve an equation to find the answer. So, we know that it was $5 each and a total of $1,000. We want to know how many times did people ride the go-karts? How many times did people ride the go-karts? So we're going to write and solve an equation. What I'm looking for is how many times they rode. So R is my ride, my number of rides. Number of rides. I know that it's $5 each, which means I'm going to multiply by the number of rides because every time it was $5. And that got me a total, so it equals $1,000. Now, I want to know what can I multiply 5 by to get to 1,000? Well, 5 times 2 gets me to 10. And then I have 2 zeros after that, so it's like I multiplied by 100. So there were 200 rides that day. Each at $5 got me to that $1,000. And that's all I have for section 2.4.